It's getting hot outside as the summer approaches. You turn on your AC, nothing hams. Now what? Well, your car's getting old, so you're doubtful of the state of charge of the refrigerant in the system. That kind of makes some sense, right? You know, you've checked the obvious stuff, the blower's working, the lights come on when you actually hit the AC switch. But beyond that, you're not really too sure. The clutch doesn't appear to be engaging, so kind of the obvious places to probably suspect what's the state of charge in the system. Make some sense? I think so, right? So you say, well, how the hell am I going to figure that out? Go and get your gauge set. Then you can hook up to the system and see what the story is, right? You don't have a gauge set. Well, that's probably pretty typical. Who the hell actually has these, right? Unless you're, you know, any of this kind of stuff. Not too many people have this stuff. The average guy in his garage, it's unlikely, right? But you think, well, you're smart enough, you know a thing or two about cars. You know that potentially you could actually get yourself in the applicable module. Maybe the engine control module, maybe the HVAC module, climate control module, whatever you want to call it. And you think, well, I can potentially pull up the parameters on that and see, I can pull up the refrigerant pressure and see what the story is. Oh, you don't have one of them either. Again, not that unusual. I have this stuff because I'm interested. Same a lot of the guys who, well, there isn't a lot, but the few of the guys who might actually be watching this, they've kind of got this stuff. They're interested in it as well. But for the average guy in his garage, is he likely to have either of these tools? Probably not. Okay, well, we're at a stretch now. How the hell are we going to figure out what the pressure is in the system without a gauge set or a scan tool to look at the PID? We have a last resort. How about this? You got one of them? There is a way through the side door we can consider the pressure in the system, give or take a wee bit, if we have one of these. Okay, so the intention of this, looking at this schematic here, boys, is not to get you to understand the AC system at large, only to put the pressure transducer, item 5, in context here. What are you actually looking at, right? So again, this is a schematic of the system as the Suzuki SX4. Big surprise. Let me show you the parts first, right? Makes sense. The compressor, the condenser coil and its fan, electric fan, the pressure transducer, the thermostatic expansion valve, and the evaporator coil inside the car, right? The one that extracts the heat energy from inside the car, the one that rejects the heat energy to outside the vehicle. So you're nice and cool inside the cab, right? So the low pressure gas comes back to the compressor, compressed of course, funny that, to a high pressure gas, goes through the condenser coil, as the name implies, condensing the refrigerant from a gas to a vapor and a vapor liquid emulsion. Is that right? What, emulsion? Yeah, let's go with emulsion. And then finally into a liquid state as it leaves the subcooler section, never mind what that means, of the condenser itself, right? So liquid leaving the condenser in a liquid state. And here's where it crosses paths with our transducer that we're interested in, our pressure transducer. So this pressure transducer senses the pressure in the line, converts it to a DC voltage, and forwards it to the engine control module for processing, let's say. So the high pressure liquid comes up to the thermostatic expansion valve. Thermostatic expansion valve basically releases that liquid into again an emulsion, part liquid, part vapor state through the evaporator. And again, as the name implies, the evaporator will convert it from a liquid back to a gaseous state and absorbing the heat energy in the cabin in the process, and then the whole system actually repeats. So where would we find it? In the SX4, again, my car, we're going to find it right here, right at the right hand wing, just inboard of course, under hood. There's two lines that run side by each, very near the evaporator, one in and one out of course. It's on the high pressure side, so the smaller of the two lines will find the pressure transducer right there. Item 8 is in fact the pressure transducer. We've got an operational amplifier in here and a splitter network. It looks like you can see here the sensing element in the system shown as a variable resistor. Perhaps there's a diaphragm, perhaps there's a piezo element in reality in there, I don't know, but this is how they've chosen to show it schematically. It doesn't matter. There's 3 wires going to it, right? One is a 5-volt feed. Take my word for it, this symbology here represents a 5-volt supply inside the engine control module. There's a 5-volt feed out, there is a ground, and there is a signal out, which is completely proportional to the pressure that the transducer is actually sensing. So that's what we're going to look at. We're going to look at these 3 wires, discern which one is the signal output, and see if we can make some sense of the voltage level relative to the pressure. Well, how the hell do we do that? Again, the Suzuki manual is good enough to give us just enough data that we can figure that out. So this is a pinout chart in the SX4 manual, boys, right? It gives you all the pins going into the engine control module, what they are and how to make sense of them, what you should be expecting at relative points of operation, shall we say. So if you recall from the schematic, it did in fact state that it was connector C1 on pin 12. What is it? It's the output from the pressure transducer. Well, what signals can we actually expect to see? Here's the relative voltage levels that you can expect to see at various operating pressures in the system. Now, I don't operate in metric here, boys, when it comes to kilopascals. PSI is my unit of choice, shall we say. You're going to see somewhere between these 2 voltages here, let's call it 1.4 volts at 116 psi in the system. When the transducer sees 116 psi, it's going to be somewhere between those 2 numbers. Just above 200 psi, somewhere between these 2 numbers. Let's call it 2.3 volts. 261, somewhere between these 2. Let's call it 2.8 volts at 261 psi. Keep it in mind, these are only pressures. They're not synonymous with the charge in the system, but it's a starting point. So, okay, so we've got three pressures here. Well, if you know these 3 pressures are going to correlate to these 3 voltages, does it make sense that we can make a wee graph and we can basically see it over the whole scale? To some degree, give or take a wee bit. I think it does, and I've done just that. So let me show you that. I couldn't find my graph paper, so I had to kind of, we're on a budget here at this channel, so you do what you can. So it just basically you can see it does appear to be a somewhat linear relationship. Now take this with a grain of salt, guys. This is no laboratory results. It's just me scaling up what data points I do in fact have from the manual and trying to make some sense of it. So with this simple graph, give or take a wee bit, we're in the ballpark. We can now find out what the hell's going on within the system. Now, let me make this clear. Do not trust this to open the system. If you take your meter and you don't read anything, that doesn't mean there's no pressure. Okay? Not by a long shot. Do not open the system if in doubt what the pressure actually is in the system. Right? So I've warned you, do not take this as gospel. As always, gloves and glasses. Anytime you're dealing anywhere near the refrigerant lines. You won't see me when I'm pinning out the connector here, boys, but wear them when you're, I was in fact wearing them when I took the connector off, because it was a wee bit stiffer to get off than I thought. So if you're putting the lines under any kind of stress at all, is wise. In fact, mandatory. So as I said, on the high side, it's kind of a wee bit of an awkward angle. It is right there. I know it's kind of really difficult to see. Bear with me a second here. See if I can get you. There's the connector. There it is, right there. So you can see that is going to be difficult to backpin in situ. So what I think makes sense is we'll remove the connector, we'll put in our probes, and then put the connector back on instead of trying to wrestle it and guess what pin we're on. So we'll remove the connector. We've got a gray and a red and a blue and an orange. So there's the connector removed there. You can see that. Here's the transducer right here where my finger is. So the connector is actually removed. As I said, it's going to be difficult to backpin that in situ. And I think you can see we do in fact have an orange, red and a blue, and that's the red with a gray stripe. Red with a gray stripe is the 5 volts, The blue tracer there's the signal, and the orange is the ground. So let's see if we can prove that. Swapped out this meter for my Vantage, and all this is a meter, so you'll get this same value on the lower line there as you would get on the display here on a standard DVOM, right? The only reason I've swapped to the Vantage is I can show it to you graphically, and it might get it might leave a clearer impression on what we're talking about with respect to the relative voltage on the respective pins, right? So I'm only going to, I've got the connector removed, as I said. I'm going to front probe both the 5-volt supply and the ground line, and then I'm going to back probe the connector and put the connector on for the actual the dynamic voltage that we'll see. That's going to be a function of the pressure. There's no point in doing that with the connector obviously disconnected, but as far as the 5-volt reference is concerned, the ground, we can check that just by front probing it. So there's the 5-volt reference. Let me just go to the ground. Again, a wee bit tricky to do this without moving everything. So there's the ground, and of course you'd be well within your rights to say, well, how do we know that's a legitimate ground? That could be just floating. Well, I doubt it, because the value is not changing for starters. But secondly, what I'll do is I'll take my ground off. So now I've got my ground actually off, and I'm going to connect this to the battery positive. So there you go, it's on battery positives. Can you see the 12 volt, the negative 12 volt supply, 12.6, that's battery voltage now in negative. If that wasn't, if there was no continuity to ground on that pin, you wouldn't be reading the 12 volts negative. I've got mechanic Matt to thank for that little trick. He's the one, he uses that frequently, and I think is a damn good one. Is it a definitive? Will the ground carry a load? Questionable, but keep in mind we're only talking about a tiny transducer here, boys. We're not talking about the headlights. There, that's the center pin. That is the red and the blue, and that is the transducer output line. Put the connector back on. Sorry about the shaky camera work here, boys. I'm trying to focus on what I'm doing and keep the camera reasonably steady at the same time. Okay, so 1.3, 1.3739 volts. Does that make some sense according to our chart that we were considering earlier? Yeah, I think it does make some sense. So just so you're clear, boys, so the red line, I should have maybe explained this beforehand. The red is actually pinned to the transducer output, as I said, and the black wire from your meter is just going to a chassis ground. Anywhere on the car is fine, right? That's obviously a viable ground. A quick look at our chart here would tell us that with 1.37, what was it? 1.37 volts. We're in and around, yeah, just a wee bit above 100 psi, I would say, there on our chart. Does that make some sense? I think so. So this is my SX4 with the functional air conditioner, boys. I know there's nothing wrong with my air conditioner here. It's working fine, so there's reasonable pressure in the system. So let me start it, and we'll see if we can get a pressure jump. The point I was just going to make there before I lost my train of thought was, with the air conditioning system shut down, with the engine shut down obviously, with the compressor not operative, the low side and the high side will balance, right? The pressure eventually equalizes on both sides, more or less. And then of course when you start the system, when the compressor kicks in, there will be quite a differential. So because we're only on the high side here, we've lost pressure in the static condition relative to the low side, which of course gains pressure unless the system is operating. So in a dynamic state, we should see a jump in the pressure here, i.e. we should see a jump in the voltage. there you go, boys. There's the system actually operating. Yeah, we're heading towards 2 volts there-ish. I don't want to have to talk over the engine running, so I'm going to shut it down. So we, if I'm not talking complete shit here, we should see a decay in the pressure. So that 2 volts that we saw, more or less, was in and around what? Just under 200 psi-ish, would you say? Somewhere close to there. Let's say 185-ish. This system is getting tired, boys. It's by no means in the optimum state of charge with respect to the refrigerant. Oh, I just lost the 5-volt ref, of course. Hang on. There we go. That should get us our 5-volt reference back. Sorry about that. I turned the ignition off. I meant to leave it in the run position, but turned the ignition off. Yeah, so you can see the point to having the graphing meter here, boys. Although it's moving at quite a slow rate, obviously. The idea was I was going to be able to show you the pressure graphed on the Vantage there. This is ancient, of course, no longer in production by Snap-on, but still a great rig. I really like it. Yeah, so there's the pressure decaying, and it will eventually go back to a balanced state. That original number, whatever it was there, boys, 1.38 or whatever. And yeah, so there was no point in me showing you that my other SX4, the system is breached. There's a leak. So of course I was not really going to get any change of state in the pressure transducer, so that's why I'm showing you my all-wheel drive one, which has an operative AC system. So I hope that makes some sense. So even without a scan tool, even without let me turn that off, that's annoying, the throttle actuator. Yeah, so of course once you lose the 5-volt ref, you're going to drop off to nothing there, boys. Clearly the transducer is not going to do it. Yeah, so where was my train of thought there? I don't know. I hope that makes some sense, that you can in fact see the state of the refrigerant with respect to how much pressure is in the system, even if you don't have a set of gauges, even if all you have is your even if you don't have a scan tool, even with just a basic mirror. And again, appreciate, boys, that I only swapped to the graphing meter for the sake of making the discussion appearing a bit clearer. I hope that made some sense. Again, you don't need a fancy mirror, you don't need nothing fancy, a basic DVOM. Just read the DC voltage, assuming of course you can correlate it. Now keep in mind, boys, I completely understand that this chart, people are going to say, well, that doesn't mean anything to me, I don't have an SX4. What the hell difference does that make? If you have a 3-wire transducer and it's not a simple switch, there is some switches out there, depending on your car, you know for a fact that is in fact a pressure transducer and not a switch arrangement. If you have a 5-volt supply, this is going to make sense no matter what. If you have 0 volts, yeah, you don't have any pressure. If you have you know, heading towards somewhere towards the upper end of the scale, I won't say 5 volts, but heading towards the upper end of the scale, you're going to have a relatively high pressure, right? Now it's possible the system could be wired in the other configuration where a low is high pressure and the high is low pressure. That's possible, but they're all pretty much the same, boys. This should hold some water in most cases, right? So I think I've dragged this out for long enough. I guess we'll leave it at that, boys. I hope this made some sense. And yeah, I'm kind of dealing with air conditioning because 1, I'm interested in, 2, obviously it's the season. So that's it, boys. I hope it made some sense. Cheers. What track is this, Stevie?
Called the Tyrone track.
Where is it?
Northern Ireland.
Oh man, madness.